This graphic illustrates a shift that has already happened. AI is the core operating system of enterprise productivity. 45% of Fortune 500 companies have AI agents in production, and 67% of developers use them for code generation nearly every day. In the past, software meant static, compiled binaries executing predefined tasks. Today, engineering terminals autonomously generate, pull dependencies, and modify code on the fly. The endpoint is no longer just a destination for human commands. It is an environment where software now initiates and executes its own tasks. Traditional endpoint detection and response tools, like CrowdStrike, were designed to monitor the execution of compiled binary malware and the behavior of suspicious process trees. This slide highlights the resulting gap. Legacy detection is blind to non-binary AI agents. Because agents use valid authentication inside developer workflows, their actions look completely legitimate. By relying on external choke points, legacy systems remain reactive, only detecting threats after malicious execution occurs. Applying legacy detection to autonomous workflows leaves the fastest-growing attack surface in the enterprise completely unmonitored. This diagram maps the interconnected agentic endpoint. Core reasoning engines like Cursor and Claude Code autonomously execute scripts, communicating through MCP servers to access restricted data. Surrounding this core are external dependencies, continuously pulling unvetted skills, plugins, and packages from public registries. Because these non-binary tools act autonomously, they open thousands of unvetted pathways directly into the enterprise network. Consider how a threat enters this ecosystem. Developers often bypass official marketplaces to install software directly, a practice known as sideloading. If a sideloaded extension contains compromised code, it can immediately instruct a local MCP server to access and exfiltrate sensitive internal data. A traditional EDR misses this sequence entirely. It scans the process tree, sees an approved developer tool using a valid authentication token, and permits the internal script to run. Because reactive tools wait for detectable events to trigger alerts, they cannot intervene during the milliseconds it takes an autonomous script to exfiltrate data. This interface demonstrates how Cortex AES, or COI, solves the visibility gap. Instead of watching from the outside, it establishes control over what runs on the endpoint by blocking risky components before installation. It achieves this using an in-process hook. This is a lightweight, sub-1 megabyte scanner embedded directly inside the AI agent's internal memory space. Sitting inside the reasoning loop allows the hook to intercept native commands like bash, read, edit, and write, evaluating them before the tool call ever executes. By operating inside the agent's memory, the system neutralizes unauthorized actions at the point of intent rather than the point of damage. The deep analysis engine actively scrapes public registries and performs cloud detonation, safely evaluating code in a sandbox. It tracks API calls across version updates, catching version poisoning attacks by blocking malware and scanning endpoints for impacted packages. For enterprise cloud AI applications, the architecture shifts to a sidecar deployment using Prisma AIRS. A sidecar rides next to the main AI application, intercepting live prompts to check for malicious injections before routing data without rewriting core code. Securing the modern enterprise requires both preemptive dynamic detonation on the local endpoint and real-time sidecar interception in the cloud. Implementing this level of control cannot slow down development cycles or force engineers to manually wrap every individual server. This dashboard shows the immediate result of a zero-touch deployment via existing device management tools. The system instantly discovers and categorizes tens of thousands of untracked agent platforms, skills, and MCP servers across the fleet. Here, we see the measurable impact on security operations. What normally requires thousands of hours of manual log stitching translates into over 23,000 out-of-policy items proactively remediated. This architecture moves an organization away from static, blind asset lists and establishes a continuously governed, risk-aware environment. Legacy security models force teams into a cycle of manual review and reactive triage. An agentic security model automates that oversight. Because it deploys as a driverless tool with virtually zero overhead, it complements existing endpoint infrastructure rather than forcing a complex replacement. To operate safely at the speed of modern development, enterprises must adopt a security architecture built specifically for autonomous tools, one that halts unauthorized commands and identity takeovers automatically. Cortex AES provides that control layer. It acts as a productivity-first guardrail, allowing the enterprise to scale autonomous innovation safely.